Good evening, children. Good evening, online students. Rajat, Rakshita, and Raghavi.
Good evening, ma'am.
Good evening. Yeah. Please. Madhavita, you said this one, right? 4 minus k into x squared. This one, right? Correct? Okay. I'll let you know. Yeah. Take down this question now. Take down this question. Online students, please take down this question. Question number 2. Please take down question number 2. Done, children? Yeah. This one, right? Yeah. Okay. We'll first work together, children. You don't write down first. You don't write down. Now, if minus 4 is a root of the quadratic equation, x squared plus px minus 4 is equal to 0. So I'm not reading the question beyond that, because here itself we have sufficient information to work something. Here itself we have sufficient information to work something. So we'll not read the question ahead. Okay. So if minus 4 is a root of the quadratic equation, x squared plus px minus 4 is equal to 0. So minus 4 is a root of, let's just name the polynomial. Okay, so let's just call it f of x. Is a root of f of x is equal to x squared plus px minus 4 is equal to 0. Okay, so if minus 4 is a root, then f of minus 4 will be 0, correct? You remember that? If minus 4 is a root, if minus 4 is a root of this quadratic equation x squared plus px minus 4 is equal to 0, that means f of minus 4 is 0. Now, how do you find f of 4, f of minus 4 in the quadratic polynomial? Wherever you have x, use minus 4. In the quadratic polynomial here, this one, wherever there is x, use minus 4. So it will be minus 4, it will be minus 4 the whole square plus p into minus 4. Minus 4 is equal to 0. See, nothing to get confused. We have this one, no? Plus px minus 4 is equal to 0. This is what we have. Wherever there is x, use minus 4, because minus 4 is a root. So wherever there is x, so this x will become minus 4, the whole square, plus this x will become minus 4. Minus 4 is equal to 0. You understand? Okay. So wherever there is x, use minus 4, and the value of that will be 0. Now 16 minus 4p minus 4 is equal to 0. 16 minus 4 is 12. 12 minus 4p is equal to 0. Minus 4p is equal to minus 12. P is equal to 3. P is equal to 3. So we found the value of p now. We found the value of p. Now let's read the question ahead. So what does the question say? and the quadratic equation, this is a different quadratic equation you can see here. And the quadratic equation x squared plus px plus k is equal to 0 has equal roots. Now we have p here and we have the same letter p here. And here we found the value of p. So you can use this value of p here because it's the same question. It's not that we are in question number 2 and we're using this value of p in question number 3. No, it's the same question. It's a different quadratic equation and the same question. And it's the same variable p, same letter p. And we've got the value of p. So you can use it here. You can use it here. So the second quadratic equation becomes x squared plus 3x plus k is equal to 0. It becomes x squared plus 3x plus k is equal to 0. Now what is given? The quadratic equation x squared plus px plus k is equal to 0 has equal roots. Has equal roots. For the first quadratic equation, it is given that minus 4 is a, for the first quadratic equation, it is given that minus 4 is a root. For the second quadratic equation, it is given that the equation has equal roots. Equal root. Two different things are given for the two equations. We have two quadratic equations. For the first quadratic equation, minus 4 is a root. With the help of that information, we are able to find the value of p. That's over. Now, the second quadratic equation, the information is it has equal roots. So we know that when a quadratic equation has equal roots, the value of d is equal to 0. When a quadratic equation has equal roots, the value of d is 0. Okay. And you can also use the value of p, I said. So that equation x squared plus px plus k is equal to 0 is nothing but x squared plus 3x plus k is equal to 0. Now d is equal to 0 because equal roots. D is equal to 0 means b square minus 4ac is equal to 0. Correct? Now what's this is a. One is a. A, B, C are numbers. Numbers meaning that the coefficients of x square, x and constant. Don't write x square for. Okay, the coefficients. The coefficient of x square is a. That means 1. The coefficient of x is b plus 3. And this is the constant c. You know that, right? All of us? Okay, so b square will be 3 square minus 4 into a, 1 into c, k is equal to 0. So when you work this, we'll be able to find the value of k. Very simple question, 4 marks. 4 marks. Right down. Write what you see here in the slide, children. Don't write on your own. Please write the answer from the slide here. Done writing, children? All of you? Online students finish writing?
Yes, ma'am.
Yes, ma'am.
Okay. I'll let you. Yeah, this is the next one. So this I'll show you the answer slide straight away. I'll just tell you one thing here. So the second equation, you see it is not in the standard form. So you'll have to open up the bracket. The second equation, the first equation is in the standard form. You can see the x squared term, you can see the x term, you can see the constant is equal to 0. So the first equation is in the standard form. The second equation is like this. Is like this, and it is not in the standard form. So you need to standard form, meaning you should be able to see the x squared term, the x term, and the constant. You should see this is the x squared term. Yeah, this is the x term. This is the constant. If a term is missing, that's okay. If the x term is missing or the constant is missing, that is okay. Okay, but whatever is there must be seen distinctly, separately. So you should see the x square term, x term constant. So open the bracket here. So it will be px square plus px plus k is equal to 0. So this is the x square term. This is the x term. This is the constant because it doesn't have x square in it. It's the constant. So whenever the equation is not in the standard form, open the bracket or whatever simplification to bring it to the standard form. Only then you will be able to get the values of A, B, and C. How will you get the values of A, B, C? Only when the quadratic equation is in the standard form. If it's like this in the bracket, how will you find the value of A, B, and C? So it's very important to have the equation in the standard form. All right? Yeah. Good, children. You may go through the answer and understand and then work. Similar to the earlier one. Good evening, Florentina.
Good evening, ma'am.
Did you take up the last online session, Florentina?
Yes, ma'am.
Were you late then? Because when I started the meeting, I did not see you. Last class Thursday.
No, ma'am, I think I joined on time, ma'am.
Okay, I didn't notice you. Okay. Did you miss any class recently?
No, ma'am.
Okay, you've been attending. Okay, okay. Fine, fine. Good. Is it over? See, now don't get confused. You can take the value of P at any point, you can substitute. Not that. Okay, see, P7, right? P7, you can substitute it at any point. P7, just make sure that here you're using PS7, that's all. There's nothing like you should substitute here only. See, like you can open the bracket. So what will you get? Px squared plus px plus k is equal to 0, right? So, and this one has equal roots. That means b squared minus 4ac is equal to 0. So what is b squared? P squared. Correct? Minus 4 into A into C. 4 into A into C. Correct? Is equal to 0. So here you can use the value of P. Where to substitute P7 is like anywhere you can substitute. Nothing that you should put it here itself or, So see here, what is it? 7 square, no? Minus 4 into 7 into K is equal to 0. So this is 49. 49 minus 28K. So is equal to 28K. Same thing you're getting. See here. I'm only trying to say that this value of P, which is 7, you can substitute in the next equation at any stage. Either as soon as you take up the second equation, like what I've done here, you can immediately put the value of P as 7. Or maybe if you forget, you come to this step, you forget and you come to this step. No worries, you don't have to go back and correct. You can continue, you can take the value of P now here at this stage. Anywhere you can substitute. But which is better? To take it in initial place itself is better. Better. You take it here itself. I'm just touching every part of the chapter so that you know what is in the chapter, and then we'll. So this is now. Okay, so solve to find the value of x. Okay. I think you can start working this, right? Yeah. I'll ask one of you to explain it. Yes. Yeah, please work this, children. Try to understand as much as possible. Your questions will be answered. Next one will be a test. Yeah, next one is a test. Yes. Arjun, the first step, shall I explain? You can understand that? Okay. What about you, Ranjan? Okay. I think you're thinking about this one. Are you looking at the answer, or you're worried about how to get this one? This which? This one, huh? Which step is it? Which step? Right side. Okay, huh? How you got this one, huh? Ah, very good, very good. Okay, okay. So that we divide by 2 throughout. We divide this equation by 2 throughout. We divide the equation by 2 throughout. You can simplify the equation like that. You can divide the equation throughout by a common factor. So when you divide by 2, you will get 2x square minus 19x plus 42 is equal to 0. And then splitting the middle term. Splitting the middle term. Then we are factorizing by splitting the middle term. Yes. How can I help you?
Ma'am,
Yeah.
ma'am, 6x square minus 10x square minus 4x square should come, right?
Which column? This one or this one?
The right one.
First column or the second column?
Second one.
Second column. Okay. Huh.
The first line, 6x square minus 10x square. After that, you wrote just 4x square. It should be minus 4x square, right?
Oh, I think I've changed the signs throughout and written the answer directly. Okay. I'm sorry. Yeah. Let me just include this step. So it will be minus 4x square, then plus 38x, correct? Minus
Yes.
84 is equal to 0. I should have included this step. Thank you, Florentina. Yes. So after this, I've changed the signs throughout. So minus 4x square becomes plus 4x square, plus 38x becomes minus 38x, and minus 84 becomes plus 84. You can even continue with the same thing, Florentina, not that you should change the signs throughout. I have changed the signs throughout that. So see, as you said, this is what we get. In the next step, what you see here, I have changed the signs throughout. Minus becomes plus, plus becomes minus, minus becomes plus. Am I clear?
Yes, ma'am.
Okay. Done writing, children? No? Finished? Yes. That's what I've missed some steps. So I've multiplied and taken everything to the other side. No, I'll show that step. I should have shown that. So it'll be what 6x squared minus 42x plus 66 is equal to 10x squared minus 80x plus 150, right? Now I've taken all these three terms to the left hand side. So then it becomes minus 10x squared plus 80x minus 150 is equal to 0. You know, you should show, I'll include this step. I've skipped a few steps. That's why it's not clear when you look at it. So you multiply like this and then transpose. Finished? No, yeah. One second. Finished? Okay. So what's the first step? Common denominator, right? So RH is 3, 1 by 3 is 10 by 3. RHS. In the LHS, the common denominator is x minus 3 into x minus 5. X minus 3 into x minus 5. So it's basically like this. No, you just multiply like this, x minus 2 into x minus 5, correct? And x minus 4 into x minus 3. Okay. Is equal to 10 by 3. Then how do you multiply these two? X into x, x squared. X into minus 5 is minus 5x minus 2x plus 10, correct? You multiply the first term. You multiply this x with both the terms, x into x, x squared, x into minus 5 is minus 5x. Then you take minus 2, again multiply that with both the terms in the second bracket. Minus 2 into x is minus 2x, minus 2 into minus 5 is plus 10. So perform the same thing here. So you're finding the product. So these are the expressions you get. And denominator also multiply is equal to 10 by 3. Now open the bracket and bring all the terms outside and simplify. Denominator also simplify the like terms. Okay, so this is fine. Then we'll have to cross multiply. Cross multiply and bring all the terms to one side. Cross multiply, bring all the terms to one side. Then on simplifying, we get this. Here itself, you can divide by 2 throughout. See, changing the signs throughout is not compulsory. It's not that you should change the signs throughout. You can even ignore the step. You can even ignore the step and directly divide by 2 throughout. Changing the signs throughout is not a mandatory step. That's just for convenience. See, if you're not comfortable with minus 4x squared, you have a minus. When you start off the equation only, you have minus 4x squared. So if you're not comfortable, change the signs throughout. Otherwise, it's not at all mandatory. So you can have that minus 4, this step as it is. You can ignore this step. If you want, you can ignore this step and directly divide this one by 2. Divide this one by 2. You'll get the same answer. Get the same answer. What I have done is I've changed the signs throughout. That is, I've changed the signs for all the terms in the LHS and the RHS. So that's how I get this one. Then I split the middle term. I split the middle term, meaning I divide by 2 throughout and then I split the middle term. All right. Okay. Finished, online students? Any questions?
No doubts, ma'am.
Okay. So here we'll all do it in the same way. So I'll just get it started for you. Now you can see that in the brackets, we have an expression and it's reciprocal. We have an expression and it's reciprocal here. In the brackets, we have an expression and we have its reciprocal here. 2x minus 1 by x plus 3, x plus 3 by 2x minus 1. So what you can do is you can say let what Dileepan, let 2x minus 1 by x plus 3 be equal to anything like a, y. Don't say x because x is already here. So of the 26 letters, don't use x. The remaining 25 letters, anything you can say. Anything you can say. So supposing I've called it y in my answer, so I'm calling it y here. Then what is x plus 3 by 2x minus 1? 1 by y. It's a reciprocal, so 1 by y. 1 by y. So now reconstruct the given quadratic equation using y and 1 by y. So it is 2y minus 3 into 1 by y is equal to 5, correct? So you'll get 2y minus 3 by y is equal to 5. Now take the LCM and proceed. Then at one point, proceed. Solve for y basically. Continue from here, children. Take the common denominator, you'll get a quadratic equation, split the middle term and find the two values for y. Yeah. So now tell me, Krishni, the common denominator is y. Yeah. Then in the numerator, 2. No. See, 2y minus 3 by y, no? If y is the common denominator, what do you have here? 1, right? But y is the common denominator. So y, 1 into what is y? 1 into y. Because y is the common denominator. You should get the denominator as y. But you have 1 here. 1 into y is y, right? So multiply that in the numerator. Now here you have y. Then what should you multiply that with? Into 1. Multiply that in the numerator. So this you're doing it in your mind. You don't have to show the steps. So here, since it is 1, it will be into y. So into y here also. So it will be 2y squared minus 3 is equal to 5. Cross multiply. Tell me, I'm writing. We'll do it together. Cross multiply. What do you get? 2y squared minus 3 is equal to 5y. Now bring all the terms to one side. Minus. Don't write 3 first. Write it in the order. Y squared, y, and then the constant. Minus
5y
minus 5y
minus 3.
minus 3 is equal to 0. So what's the sum?
Minus 5.
Minus 5. And what about the product?
Minus 6.
How do you get that? 2 into minus 3. Minus 6. Correct? Can you recall this, children? This is the sum. This is the sum. Minus 5. This is the sum. The product is 2 into minus 3. 2 into minus 3 is the product. So what are the two numbers that satisfy the sum and the product? Minus 6 and 1. Yeah. So the two numbers, required numbers are minus 6 and 1. Because when you multiply, you will get minus 6. And when you add, you get minus 5. So 2y squared minus 6y minus 1y or y. Sorry, plus. Minus 6y plus y. Minus 3 is equal to 0. Yeah. Now group this and find the value of y. Once you find the value of y, put it back. What is y actually? 2x minus 1 by x plus 3. So supposing you get y is equal to 5. Yeah, you can continue. Supposing you get y is 5. So 2x minus 1 by x plus 3 is equal to 5. Both the values of y. Both the values of y. And you'll get two different values for x.
Sum is y plus 3.
The other value of y, two values of y.
One is 1 by 2, another one is 3.
No, I have a different answer.
Is it minus 1 by 2 and 3?
No. Yeah. My God, but I saw something else. No, is this the answer? This is the answer, right? Oh my God. Oh, you were talking for y, is it? I'm so sorry. Oh, no, I saw the values for x project. Sorry, yeah. Y is 3 minus 1 by 2. Did you say that?
Yes, ma'am.
Sorry. Yeah. I mistook it to be the values of x and I was looking at the answers for x.
No problem.
Yeah. Yeah, you're right. Please proceed. Yeah. Once you find the values of y, you said 3. So 2x minus 1 by x plus 3 is equal to 3. I'll just show you this right here. So see here, children, you need to proceed like this. After you get the values for y. But what is y? What is y? 2x minus 1 by x plus 3. Ranjan. Okay. Once you get y is 3, y is minus 1 by 2. What is y? y is 2x minus 1 by x plus 3. Correct? So y means 2x minus 1 by x plus 3 is equal to 3. Or y, again y means 2x minus 1 by x plus 3 is equal to minus 1 by 2. This again you should cross multiply and work and you'll get the values for x. All right? Yeah, do it. Done? Any questions? Yes, Ranjan. Second for the right side column. No. Here. Plus sign this one. Huh? Yeah, transpose of 2x minus 3x is equal to 9 plus 1. Or you will get when you transpose 4x minus x, when it comes here, 4x plus x, right? 5x is equal to minus 3 plus 2. So minus 1. Transposing. So that's what I've written. Since I've written it directly, so you'll get minus x is equal to 10 or x is equal to minus 10. Yeah, yeah. You'll get minus x is equal to 10 or x is equal to minus 10. Done, children? Just take that power question. Yeah. Solve for x. Okay. So this We have x to the power 2 by 3. Now we know that 2 by 3 can be written as 2 into 1 by 3. 2 by 3 can be written as 2 into 1 by 3. Okay, so let's write 2 by 3 as 2 into 1 by 3. The power 2 by 3 as 2 into 1 by 3 plus 5x to the power 1 by 3 is equal to 50. All right. Now there's nothing but x squared, the whole power 1 by 3. Remember the law of exponents? When there are many powers, we multiply the powers, no? So we are writing the earlier step. It should have been x squared the whole power 1 by 3. That's why you are multiplying the powers, x to the power 2 into 1 by 3. We're writing the previous step. See, you're writing, you have x to the power 2 into 1 by 3. So you have multiplied the powers, no? So the earlier step should have been x squared the whole power 1 by 3. The earlier step, x squared to the power 1 by 3. So you have multiplied the powers 2 into 1 by 3. Like that. Okay, and write it again. So x to the power 2 into 1 by 3 plus 5x to the power 1 by 3 is equal to 50. Now this becomes x squared, the whole power. But we have to write 1 by 3 inside. You can write anything now again. Let me clarify that also. Now when you have x to the power 2 into 3 like this, you can write x cubed the whole square, or you can write x squared the whole cube. Anyways, you can write, correct? When it's x to the power 2 into 3, you can write it as x cubed the whole square, or you can write it as x squared the whole cube, correct? Both are the same. Both is 3 into 2, 2 into 3. Okay, so write it as x to the power 1 by 3, the whole square. You want to have x to the power 1 by 3. You don't want x square because you have x to the power 1 by 3 here. You want to have x to the power 1 by 3. You don't want x square. I wrote x square first, no? Then I said no. You don't want x square. Because you have x to the power 1 by 3 here, you want x to the power 1 by 3. So put the square outside. Okay, so plus 5x to the power 1 by 3 is equal to 50. Correct? Now you say let x to the power 1 by 3 be equal to y. So now when you substitute, when you replace, x to the power 1 by 3 is y square plus 5 into y, correct? X to the power 1 by 3 is y, so 5y minus 15 is equal to 0, correct? Now you'll have to split the middle term, and all that you get a is equal to 5 or a is equal to minus 10. See, when you work with this, I have taken y, children. I have taken y. Here I've used a. So you will get a is 5 or a is minus 10. Is that fine? Okay. Now who's a? Who's a? A is x to the power 1 by 3. Who's a? X to the power 1 by 3. So if a is 5, that means x to the power 1 by 3 is 5. If a is 5, okay, that means x to the power 1 by 3 is 5. Okay, so if a is 5, that means x to the power 1 by 3 is 5. Again, a is minus 10 means x to the power 1 by 3 is minus 10. Now, how do you find the values of x? Now, in order to get rid of this, 1 by 3, raise both the sides to the power 3. Raise both the sides. See, you can do any action, any same action on both the sides. You can do any same action on both the sides. Okay, so you want to find the value of x, but you have x to the power 1 by 3. You don't want 1 by 3. You want to get rid of 1 by 3. How will you get rid of 1 by 3? 1 by 3 into 3 will become 1, no? 1 by 3 into 3 will become 1. You want to get rid of 1 by 3. You don't want 1 by 3. So 1 by 3 into 3 is 1. So what you do is you raise both the sides to the power 3. Supposing it was x to the power 1 by 4, then you should raise both the sides to the power 4. If it was 1 by 5, raise both the sides to the power 5. So accordingly, not always raising both the sides to the power 3. It depends on what you have. So here, because we have 1 by 3, we raise both the sides to the power 3. So see, this whole thing to the power 3, 5 cube. See, can you see this? This one to the power 3, this one to the power 3. Correct? So here what will happen? 1 by 3 into 3 is 1, right? 1 by 3 into 3 is 1. So x you'll get. X is equal to 125. Here also 3 and 3 will get cancelled. 3 and 3 will, because 1 by 3 into 3 is 1. So you'll get x is equal to minus 10 to the power 3 is minus 1000. All right. Do this. Yeah, about this, children. So here also you can take this first step, like take the question. I can add this step. You can write this as your first step and then continue. In the solution, let this be the first step. In the solution, let this be the first step. Then you can continue with what you see in the slide. Finish, Oliver? So we start this one. We write x to the power 2 by 3 as 2 into 1 by 3. And then this can be written in two ways. This can be written as x to the power 2, the whole power 1 by 3. Or it can be written as x to the power 1 by 3, the whole square. So you have to choose between the two. So we go with this one because we can assume x to the power 1 by 3 as some other variable, y, z, or a, whatever. We don't go with this one because we already have an x to the power 1 by 3 in the equation, correct? Online students finished working this? Any questions?
No, ma'am.
And this part, once you get a is equal to 5, a is equal to minus 10, what do? What is a? A is x to the power 1 by 3 is equal to 5. And a is x to the power 1 by 3 is equal to minus 10. So we have to find the values of x. So which means we have 1 by the power 1 by 3. We don't want this. So how will you remove this? By multiplying this by 3. When you have 1 by 3 power, when you multiply by 3, you can cancel out and you'll get rid of the power 1 by 3. It becomes 1. So that means you should raise both the sides to the power 3. Raising both the sides to the power 3. So this is 1 by 3 into 3. So it will become x to the power 1 is equal to 125. Similarly here, when you raise this to the power 3, both the sides to the power 3, 3 gets cancelled. So we get x is equal to minus 1000. All right. Yeah. So here we have 2 to the power 2x minus 3 into, it's not 3.2, it's not 3.2, it's 3 into 2 to the power x plus 2 plus 32 is equal to 0. Now we'll have to keep writing the previous steps. Okay, so now this can be written as, this one can be written as 2 to the power x, the whole square. Correct? You can also write it as 2 to the power 2, the whole power x. We'll see which one. See, maybe we don't need this. We might need this version. We'll see. Just write. But you want 2 to the power x. You want 2 to the power x. Okay. Anyway, see, these are the only two ways. 2 to the power 2x can be written as 2 squared the whole power x, or 2 to the power x the whole square. Any point you can change it if you want. If you feel we have taken the wrong one, you can any point change it. Okay, so now we write it like this. 2 to the power x the whole square, correct? Because 2x means what? 2 into x. What is 2x? 2 into x. 2 into x meaning you can write it. This is x into 2 or 2 into x, right? Multiplying the powers. Okay. All right. Minus 3 into the earlier step, 2 to the power x into 2 to the power 2. It should have been like this. It should have been 2 to the power x into 2 to the power 2. Bases are same, it's multiplication. So we add the powers and we get 2 to the power of x plus 2. We're writing the previous step. How can you get this one as the answer? The previous step would have been 2 to the power x into 2 to the power 2. The previous step. Bases are same, 2, 2. It's multiplication. So we add the powers, 2 to the power x plus 2. So if you want to write the earlier step, the power is x plus 2. So write it separately, 2 to the power x into 2 to the power 2. If it was 2 to the power x minus 2, then you must say 2 to the power x into 2 to the power minus 2. Whatever be the sign, plus minus, don't put it like that, write it as 2. Or if you want, you can write it as 2 to the power x divided by 2 to the power 2 also. Because when bases are same and it's division, we subtract the powers. When bases are same and it's division, we subtract the powers. So you can write 2 to the power x minus 2 as 2 to the power x divided by 2 to the power 2. Division, so we have to subtract the powers x minus 2. So we are writing the earliest step. The earliest step. So coming again, 2 to the power x the whole square minus 3 into 2 to the power x plus 2. So we write as 2 to the power x into 2 to the power 2 plus 32 is equal to 0. All right. Now 2 to the power x the whole square minus 2. This is the product, right? 2 square is 4. 4 3s are 12. 2 square is 4. 4 3s are 12. So 12 into 2 to the power x. You cannot multiply these two and write 24 to the power x. That's wrong. You cannot multiply these two. So 12 into 2 to the power x plus 32 is equal to 0. So now we can substitute. Let Dileepan what? Let yeah. Oh, sorry, Ranjan. Sorry. Yeah. What is your favorite letter? Which is your favorite letter? Tell me. X, huh? S. Okay. Shri Ranjan. So S. All right. So it will become S square minus 12 12s plus 32 is equal to 0. So this is a quadratic equation in S. So you'll have to split the middle term and find the value of S. See here. Oh, I don't have the answer. Okay. Then we have to work it. Please find the value of S and then we'll have to continue. That's not the end of it. You can take your favorite letters. You don't have to, you're not forced to take S, all of you. You can take Y or any other letter.
Ma'am, I'm getting two values for S, ma'am.
Yeah. What are they?
They're 4 and 8.
4 and 8. So S is equal to 4 or S is equal to 8. That means what is S? 2 to the power X is equal to 2 square. 4 is 2 square. So when base are same, it's when base are same on both the sides, you can equate the powers. You can equate the powers. So you get X is equal to 2 or 2 to the power X is equal to 8. 2 to the power X is equal to 2 cubed. 2 to the power X is equal to, sorry, X is equal to 3. Got it? Very good. When bases are same on both the sides, we can equate the powers. Sure. Yes. You got S48? You got that? Okay. All of you? Sushmi, what is the sum? What's the sum? Sum is minus 12. And the product is 32. What are the two numbers? What are the required numbers? Minus 4 and? Because the product is 32 and the sum is minus 12. Okay, so I'm splitting the middle term. So s square minus 4s minus 8s plus 32 is equal to 0. So s is equal to 4 or s is equal to 8. Now, what is s actually? 2 to the power x, right? 2 to the power x is equal to 4. Now, here we have base 2. So how will you write 4 in base 2? 4 is 2 square. 4 is 2 square. Now again, there is a law of exponent which says that on either sides, when bases are same, on either sides of the equal to sign, when the bases are same, you can equate the power straight away. So you can see that the bases are same. It's like you can cancel the bases 2 on either sides. Don't cancel. I'm just showing you like that. So x is equal to 2. Bases are same on both the sides. So you can equate the powers and hence you get x is equal to 2. X is equal to 2. Here s is equal to 8. So 2 to the power x is equal to, sorry. Okay. S we already have 8 there. So 2 to the power x is equal to 8. 2 to the power x is equal to 2 cubed. Again, 2 gets cancelled on both the sides. Like bases are same. So equating the powers, we get x is equal to 3. So the values of x are 2 and 3. All right. All right. I don't complete it. Okay. We do this together. I'm not explaining this. Even I'll work, you also work. What's the next question, children? Sorry. Y is equal to 1. Yeah. That means 3 to the power x is equal to. Okay. That means. Very good. Very good. That's why I did not continue. 3 to the power x is equal to 3 to the power 0 because 1 is anything to the power 0 is 1. So you should write 1 as 3 to the power 0 because here we have 3 to the power x. So we must write 3 to the power 0 because anything raised to the power 0 is 1. So again on comparing, we get x is equal to 0. Base are same, so equating the powers, we have x is equal to 0. Or 3 to the power x is equal to, yeah, okay, 1 by 9. Yeah, so it will become 3 to the power x is equal to 3 to the power minus 2. So x is equal to minus 2. Very good. Then all of you? Okay. So 1 should be written as 3 to the power 0. If we had 5 to the power of x, then we should write 5 to the power 0. Then only we'll have the same base, so you can equate the powers. And what is 1 by 9? 1 by 3 square. And 3 square, when you bring it to the numerator, it will become 3 to the power minus 2. 3 to the power minus 2. So x is equal to minus 2. Find the value of. Okay, find the value of this expression. Now take down the question. Oh, online students, did you finish the earlier one? Any questions here, children?
No, ma'am.
This one? Any? Not this. All of you finished?
Yes, ma'am.
Okay. Right. Ready? Okay. Okay. So square root of 6 plus square root of 6 goes on like this to infinity. Okay, so we are able to find the sum. See, we are able to find the value of this expression because at a point the value will become so small that it will tend to 0. That's why you're able to find the sum. See now, if the question is find the sum like 2 plus 4 plus 6 plus 8, you cannot get one. You cannot find the answer for this one, right? What is 2 plus 4 plus 6 plus 8 plus 10 plus 12? You cannot find a numerical answer for this because it goes on. It's infinity. It goes on and on. Then how can you find the value of an expression like this? Because when you take the square, when you continuously take the square root, the values shrink and it becomes so small that at a point it will become 0. 0 meaning it will be some 0 point, some 100 zeros and 1, or some 1,000 zeros and 1. So it becomes so small that it's almost 0. So because we have the numbers under the square root, at a point the numbers will become so small that it will almost be 0. And that is why we are able to find the sum here, the value of this one. And what do you think about the sum? Will it be positive or negative? This one, the answer for this one, can it be negative? The answer for this one cannot be negative. You understand? No, can the answer to this one be negative? No, the answer for this one cannot be negative. It's square root of, and again under that square root. So it cannot be negative. The answer to this cannot be negative. Okay. So to start off, we'll say let this be equal to x. That's the first step. Let this be equal to x. Okay. Next, we'll square it on both the sides. We'll square on both the sides. Let this one be equal to x. Then we'll square on both the sides. So what happens when you square? This square root will be eliminated. This one will go away, correct? This square root will be eliminated. So you will have 6 plus, then again square root of 6 plus square root of 6 plus square root of 6. It goes on. Is equal to x squared, correct? When you square it, the square, because of the square root will be eliminated. This one will be eliminated. So you'll have 6 outside, plus again square root of 6 plus square root of 6, it goes on to infinity, is equal to x squared. Now next step, 6 plus, we had actually called this one only as x, no, when we started off. When we started off, we called this one as x, right? Is equal to x squared. So like this, you get a quadratic equation in x. X squared minus x minus 6 is equal to 0. You need to solve this quadratic equation and find the value of x. You will get two values, one positive and one negative. Ignore the negative value, take the positive value. All right. Please work, children. Done, children? No, sorry. Okay, so as I said, first assume the given expression to be x. And then to get rid of the square root symbol, we square on both the sides. We square on both the sides. So when you square on both the sides, the square and the square root will be eliminated. So you have 1, 6 out like this, and the rest will continue. Root of 6 plus root of 6, it goes on. Okay. Then since we have called this one as x, it will be 6 plus x is equal to x squared. And then we get a quadratic equation, split the middle term. We have x is 3 or minus 2. But you can look, when you look at this expression, you know it cannot take a negative value. So x is not equal to, x cannot be a negative 2, x is equal to 3. See, then why are we getting a negative answer is, we have a quadratic equation. Both these values will satisfy this equation. So we are getting 2 answers. But this answer will not satisfy this expression. So we reject it. See, we get 2 values, both are accepted actually, both are fine. Both these values will satisfy this quadratic equation. That's why we're getting these 2 answers. But the thing is, these two will satisfy this quadratic equation. But when you look at the expression given, you need to justify. Now, this expression cannot, see, for the first thing is, one thing cannot have 2 answers. That's one thing. See, this expression, I cannot give 2 answers for this, right? This expression can have only 1 answer. In the first place, it can have only 1 answer. Can I give 2 answers for this expression? No. The sum can have only 1 answer, right? Shashank, something's making you think. Okay, this the first thing is, this one can have only 1 answer. And that 1 answer can be either 3 or minus 2. But you know that this cannot be negative. So we reject this and take the positive one. All right. So all these sums, children, I'll put it in the portal because it's just taking LCM and all that, you know, we can't do so many sums in the class here. School finally reopens on 12th, is it? But once school begins, when you're in your vacations, you want school. But once school begins, you know, and that hectic routine, you will feel, oh, it was so nice in the vacations. You know, we are never happy with anything. And the trauma is if you have school on Saturday. The biggest trauma is if you have school on Saturday. Yes, children. So here again, solve for x. Okay, so these are standard questions. If you, you know, like get started in a particular way, it will smoothly lead you without any, with less effort, you can reach the answer. If you want to try it in different ways, you try it. But how long you will take to get the answer, even I don't know. Because you can just experiment different ways, right? You can experiment different ways. You will get it, but I don't know how long after you will get the answer. So standard questions have a specific way of, you know, like a specific approach. When you use that approach, you can easily get the answer in fewer steps. Okay. So from here, I'm just going to explain. You're not going to write anything now. I'll share the presentations. You can complete it as homework. Okay, no, there's a test later. Yeah. Okay, children. Fine. Children will not write from here. I'll share the meaning. You can, online students have an advantage. You can take a screenshot now itself. Complete this by the next class on Thursday. All of you. Okay. Okay. So this is the given equation. The first step is to transpose only this one. The first step is to transpose 1 by x plus 1 by x. So when it comes to the other side, it will become minus 1 by x. All right. Now take the LCM on both the sides. Like this is like the constant, no? Because there's no x here. 1 by a plus 1 by b. Like there's no x there. But these terms have x in it. So we are basically gathering the x terms. See, this one has x here, and this one also x has x. So it's like we're just grouping, we're just gathering the x terms on one side and the terms that don't have x on the other side. That's all we're doing. Okay. So these two have x terms. These two do not have x term. Okay, like that we group. So first step is to transpose this one. Okay, then LCM. What's the LCM? The product x into a plus b plus x. X into a plus b plus x. That's a common denominator. This one into a plus b plus x is the common denominator. Then what will happen to the numerator? It's like cross multiplying, no? It's a cross multiplying, right? 1 into x is x. And okay, it's so difficult to explain this now. This is x and this will become. Okay, 1 minute. This is the denominator here, this is the denominator here. But this is the common denominator. So what you have in this denominator, you have a plus b plus x. You have this a plus b plus x. What is not there? This x is not there. So you should multiply the numerator with that x. Whatever is not there in the denominator, multiply the numerator with that. I'll tell you again. This is the common denominator. Look at this denominator and this denominator, the common denominator. What is missing? This x is missing. So multiply the numerator with x. Now look at this denominator and the common denominator. X is there. What is missing? This one is missing. So multiply the numerator with that. Multiply the numerator with that. You've taken something as the common denominator. So compare the denominator you have with the common denominator. Whatever is missing, multiply the numerator with that. So 1 into x is x minus, and 1 into this one is the same thing. 1 into x is x minus 1 into this is the same thing, but put it in the bracket because there's a minus here, no? Put it in the bracket. Okay. So that's the first step. So here AB is LCM, so you get B plus A by AB. Open the bracket. Open the bracket. So it will be x minus A minus B minus x by x into A plus B plus x is equal to, you can write this B plus A as A plus, you can write this B plus A as A plus B by AB. All right. Now what happens here? Cancel the x and minus x gets cancelled. X minus x cancelled. So we have minus A minus B. Minus A minus B can be written as minus of A plus B. You can take a minus common and then write as minus of A plus B. Is it cold or something? Should I turn off? So minus A minus B can be written as minus of A plus B. Actually, ever since I got AC installed, I have not learned how to use a remote. This one is different from what we normally use. For me, it is different, so I really don't know how to use it. I've just been turning it on and setting temperature. That's all. The other features, the how to maintain the swing and all that, I'm doing fine, but it's just not working. It's quite complicated for me to understand. So I need to watch a YouTube video to, understand how to use a remote, and then probably in the classes to come, I'll set it correctly. Now it's like hitting on the face, right? Yeah. Yeah, so I think by next class, every time I think I should come half an hour early and, like learn it, but just come on. And no, I need to turn that lower. See, I just have to adjust it. I have to put a stool, get on there and just turn it so that the throw comes to that side of that portion also. I've not been able to do that. It's very heavy here. There it's very warm. Correct. We are in different parts of the world in the same class. I'm in Antarctica. Probably this is some other cold place that is Trichy only. Okay, that's what it is. I just need to adjust. Once I turn it, you will get it there. So minus of, I said minus A minus B, take out minus common, so it will be minus of A plus B. That's what you have here. Here, okay, this one gets cancelled. like this. Okay. Now again, this a plus b on both sides gets cancelled. Minus is there. Minus will remain. A plus b on both sides gets cancelled. Now cross multiply. So you will get this one. This one is equal to this. When you cross multiply, this is cancelled out. So you have 1 here. When you cross multiply, this one is equal to this one. So you'll get x into a plus b plus x is equal to minus ab. Now open the bracket. Bring all the terms to one side. And now how do you rearrange? That's very important. Now how do you rearrange? Bring all the terms to one side, but how do you rearrange? Write x square term first, then write the 2x terms, and then write the constant. Write the x square term first, then write the 2x terms, and then write the constant. Arrange the terms in this order. Write the x square term first, and then the 2x terms, and then the constant is equal to 0. Now there is nothing like splitting the middle term. The middle term is already split. That's why we have 2x terms. When will you have 2x terms? When you have 2x terms, you can continue factorizing. You don't have to do anything else. There are 2x terms. So group the first two terms, group the last two terms. X is common. X into x, x squared, ax. Here b is common, is equal to 0. So x plus a, write it once. And then x plus b in the other bracket is equal to 0. So x is equal to minus a or x is equal to minus b. So just one simple thing you have to do. There is x here. This one has x. So transpose this x to the side. So here we have the x terms here and the ones which don't have x here. Take the LCM. And yeah, that's it. Nothing else. Actually, this a plus b plus a, we wrote it as a plus b. This one gets cancelled. Minus common we took. This one gets cancelled. Cross multiply and we get the result. So transposing 1 by x is the key here. Now your question will be, what if I take the LCM like that itself? Really, I don't know. I have to work. You will get the answer. Maybe in 2-3 pages you will get it. I don't know. It's a standard version. This is the easiest approach to getting the answer. And I explained why we transpose 1 by x. We are basically collecting the x terms on one side and the ones which do not have x on the other side. That's the reason. Online students? Any further questions?
No, ma'am.
Okay. So basically almost the same here. No? So 1 by 2x. 1 by 2x it is. So see here, I've transposed that. This 1 by 2x, I've taken it. You can see here, this 1 by 2x. We take to the LHS. So minus 1 by 2x is equal to 1 by 2x. Same thing. Very similar to the previous work. Okay, you just watch the answer, meaning go through the answer and ask me if you have any doubts. Yeah, children, please go through the answer. Very similar to the earlier one. Okay, so exactly like the earlier one. So here this minus 2x and plus 2x gets cancelled, taking out minus common. Then this 2a minus b, 2a minus b gets cancelled, cross multiply, bring all the terms to one side and arranging it in the correct order. Write the 4x square term first and then the 2x terms and then the constant is equal to 0. Same thing. So what is the first step? Transposing this. Then LCM. Transposing this is the first step. Then common denominator. This is the common denominator. Then this will get cancelled. And then we take out minus common. After taking minus common, you can cancel out these two. Then we cross multiply and we open up the bracket also. We open up the bracket here. We cross multiply and we open up the bracket and we bring all the terms to one side. Once you bring all the terms to one side, you need to arrange the terms in the correct order. So the x square term first and then the 2x terms. When you write the 2x term, write ax first and then bx. Then plus 2ab. This one has no x term at all. X term, not x term. It does not have x as a factor here. X 2ab. So it's a constant is equal to 0. Then group the first two terms. Group the first two terms. Group the last two terms. And hence find the values of x. All right. We'll do this one and then we'll just take a test on polynomials. Now here, what you have to do is, again, the starting, how you get started is very important. So here you have a by b and b by a. Now can you see something like a by b here? And can you see something like b by a here? So what you do is, you transpose, you bring everything to one side. Okay, x minus a by x minus b. Okay, there's something like a by b here. So have group this with minus b by a. That is this plus b by a when it comes to the other side, minus b by a, right? This plus b by a when it comes to the left-hand side, minus b by a. That you group with this one. Then plus x minus b by x minus a. This has something like b by a. So minus a by b is equal to 0. So basically, you're going to transpose. You're going to bring these two terms. You're going to bring these two terms to the left-hand side. To the left-hand side. When you bring them to the left-hand side, let this a by b go with this b by a, and let this b by a go with this a by b. When you bring them to the other side, it will be minus a by b minus b by a, correct? That's all. That's the starting, and then LCM, same thing. Yeah. So, as I told you, this is the first step. Okay, and then LCM. I just enclosed it in a bracket. Then it's about taking the LCM. So this is that LCM step. This LCM step is equal to 0. Basically, what is it? A into x minus a plus b into x minus b. That's what you see here, LCM. A into x minus a, b into x minus b, LCM. Then you open up the bracket in the numerator. Here, after taking the LCM, here in the numerator, open up the bracket. So you get all these terms. And then again, look at the terms very carefully. Look at the terms here very carefully. Ax, a square, bx, b square. Ax, a square, bx, b square. We have the same thing almost. We have almost the same thing. See here, ax, bx, a square, b square. Ax, bx, a square, b square. So it's almost the same. So what do? You just try to arrange the terms in the correct order, and maybe we have to take out something minus or something common. So we'll see what happens. Now see here, ax minus bx minus a square plus b square minus a square plus b square. So here minus ax plus bx plus a square minus b square. Now I've taken a minus common because the signs are exactly the opposite. If you compare the signs are exactly the opposite. If it's plus ax here, it is minus ax here. If it is minus bx, it's plus bx. If it's minus a square, it's plus a square. If it's plus b square, it's minus b square. Exactly opposite signs. So you take out a minus here. You take out minus. So that means this plus sign will become minus. This plus will become minus. So in the bracket, see, basically you're taking out a minus sign. When you're taking out a minus sign, putting this in a bracket. So what will happen to this minus plus? This plus minus, this plus minus, this one plus. Signs will change. Now you have taken out a minus sign, so that minus into this plus connecting sign will become minus. Minus into plus will become minus. So many steps you don't have to show. So you can directly, when you take out a minus common here, when you take a minus common here, that minus into this plus will become minus. Put it straight away. And change the signs. All the terms just change the signs. Is this difficult to understand? Take out a minus common. When you take out a minus common, it will be here like this. And the signs will change for all the terms in the bracket. And that minus and the plus outside will become minus. That's why minus here. So that step you don't have to show. Understood? You're in 10th standard. No, that's why. Now, you can, now children, you don't cancel, meaning there is x here, right? Whenever you cancel, if expressions that have x, you cancel expressions that have x, you may lose one value of x. You may not get both the values of x. You may lose one value of x. So you cannot cancel is a different thing. See, like 1 minute. Supposing we have x by a minus x by b is equal to 0. Actually, when you transpose this, x by a is equal to x by b, then we can cancel, no? See, now it's like minus here is equal to 0. Just imagine you take it to the other side. Imagine you take it to the other side. Okay, so then it will become, okay, it's easy to show then. It'll be like this, right? Equal to it will become. It'll go to the other side as plus. Now you will say that I'll cancel this. It's the same. That's what you told us earlier. In some sums, you asked us to cancel the numerator. There we cancel because mostly we had a plus b. We didn't have x there. Yeah, see, we didn't have x there. You can cancel. You can cancel when expressions don't have x in them, x or x squared, you can cancel. Because you will get both the values of x. But if you have expressions that have x in them, now I said if you take this to the other side, if you take this to the other side, this is equal to 0 will go away, and this minus will become equal to, right? Then you will say, then I'll cancel, both are the same, so I'll cancel the numerators. You cancel, what will happen? You'll get only one value for x. You will not get the other value for x. Whenever there are expressions with x in them, do not cancel them because you will lose one value of x. So now you can, what should you do then? Take out that expression common. Take it out common. So the numerator is common. This one, that's common. Bring it out. Bring it out. Ax minus bx minus a square plus b square is common. Bring it out. Am I clear, children? Bring it out common. Don't cancel it. So now you'll get 1 by, no, please understand this. After when you take out this one common, then in the bracket you'll have 1 by a into x minus b minus 1 by b into x minus a is equal to 0. Again, it's again common denominator. It is tedious, but it's easy. It's not difficult. It's easy, but thing is very lengthy. So again, common denominator. You can see I've multiplied the denominators. So this into this and this into this. So here it will be bx minus ba, ax minus ab. Here you put it in the bracket. Okay, when you take the common denominator, what will happen here? I'll just extend this. What will happen? This one will go away. So what will you have here? B into x minus a. minus a into x minus b. This will come here. This b into x minus a will come here. Minus a into x minus b here. So what do you get? Bx minus ab, bx minus ab, minus ax plus ab, minus ax plus ab. I'm showing you. See, I'll show it again. When you take the LCM, this will become the common denominator. This is the common denominator. So here you will get this one, this b into x minus a. B into x minus a you will get here. Minus, here you will get a into x minus b. Correct? So then it will become bx minus ba or ab minus ax plus ab. Bx minus ab minus x. All it? Okay. Is equal to 0. Now, there is no choice. You have to cross multiply, right? You have to cross multiply. There's no choice. Now, when you cross multiply, this one into 0 will become 0. That's why in the next step, the denominator vanishes. The next step, you don't see the denominator. Where did the denominator go? We cross multiplied. So into 0, it's 0. So finally, it becomes a little lighter. The equation becomes a little lighter without this one. On cross multiplying, this is lost. Okay, you have only the numerators here. Now in the numerator, this one and this one gets cancelled. So this is what remains. That's all, we got the answer. So the product is 0. The product is 0. The product is 0. That means either this is 0 or this is 0. So if this one is 0, if this one is 0, if ax minus bx minus a square plus b square is 0, find x. Find x. So ax minus bx is equal to transpose a square minus b square. So take out x common. A minus b is equal to a square minus b square. So x is equal to a square minus b square by a minus b. And what is a square minus b square? A plus b into a minus b by a minus b. This gets cancelled. So x is equal to a plus b. On the other side, here when you take out x common for this, when you take out x common, b minus c is equal to 0. So this b minus a will come for division to the other side, no? B minus a. So x is equal to 0. X is equal to 0. One value of x is 0. The other value of x is a plus b. Understand, children? This is the continuation of this one. One value of x is 0 because this b x into b minus a. When you take out x common, x into b minus a is 0. So x is equal to 0 by b minus a. So x is 0. So how do we solve for x? You'll have to take out x common. The constants take it to the other side. This a square, b square, put it to the other side. And here x is common. X into a minus b. Then that a minus b goes for division. A square minus b square is a plus b into a minus b. So a minus b gets cancelled. X is equal to a plus b. It's actually very simple. It takes a long time. You need to work it very carefully. Somewhere plus minus you make a mistake, or instead of a b you write only b or a square or whatever. You cannot find a mistake. It's very difficult. So these questions you should do it correctly in the first shot. It's boring to just imagine in the examination. Will you have the like the patience to go through where you've gone wrong? No, you'll be so tensed. You can't make out where you've gone wrong. Some minus plus sign, somewhere you're wrong. You really cannot see. So you should work this. Take 2-3 minutes extra, but work it correctly in the first shot. If you numerical sums, you can do it. You can strike it out and do it again. Numbers. But these letters, it's very difficult. You can't make out what is wrong. You do it carefully. Do it very carefully. So these are standard questions. If fast, it will come like this only. There'll be no change. If you get a question like this, you'll get the same thing. There'll be no change. And questions like this will be asked mostly in school level exams. Board exams, now it's become very diluted. Board exams are very, very easy now. Nowadays, like in comparison to what it was earlier, easy meaning the correction has become easier. It's like everybody's getting 90, 95. Only the teacher knows who deserves 100, who deserves 90. Only the teacher will know. Otherwise, everybody is getting 80, 90. Mostly people are getting 80. Whatever be the in the paper, they're getting mostly it's 80. I don't see anybody failing. I don't see anybody flunking the board exams at all recently, right? No. In my generation, people used to fail in the board exam. They used to repeat the 10 standard. So we'll at least one of the seniors will study with us. Like when we are, sorry? Yes. And then children had that strength to study with the juniors. She'd been, because it happened in my time. So there was a girl who was in my art class. She was our senior. She missed the exams, and so she had to study with us. No, sorry. No, I don't think. I think in the ICSE board we did not have that September exam coming. No, we didn't have. We had to take the annuals. That it was like that at that time. She studied with us, and it was no mocking. She was our friend. It was difficult to mix with her because we had seen her as our senior, and suddenly our classmate was a little difficult to accept. But then, yeah, now children don't have that strength actually. That's why we are becoming weaker and weaker. Mentally, we have become weak. We are becoming weaker and weaker. Actually, that's the truth. Yes or no? We are becoming very weak, and like everywhere, so that mishappenings don't happen. Everybody is diluting the procedures and all that. Like I think now nobody fails the 10th and 12th boards easily. Mostly all of us pass. All of us pass. Good in one way. That itself we see, children, they take up the NEET exam and they don't get what they deserved, and they take up some extreme steps. So it's so pathetic. All of us want to become doctors. So that there's a lack of, communication between, so students who are preparing for NEET must be counseled and, must be given that mental strength to accept whatever be the result. That should be the teaching first in such classrooms. But it's not like that. There's always a competition, they announce classroom rank, then if there are many centers in that region, then all the centers put together a rank, then district rank, then South region rank, then, ranks at different levels, then that all India rank. So you may be the topper in your center. Then when it comes to that, whatever, when it goes up to the zone and district, then you may be like the 50th rank. Then you move to 100, and then you're the 1000th rank. You can't accept it. You can't accept it. The children must be taught to take things easily. So that should be the teaching first. Life is not at all about marks. Seriously, my classroom, there was a boy called Pushparaju. He was, I shouldn't say that, but he was a person not, like known to exist in my class. He used to just come and go, and he used to pathetically flunk in all the subjects, mostly. He has never passed anything. Somehow he managed to get through the 10th boards, and we were like surprised. How did this guy? The meeting is recorded. I hope this video doesn't reach him. So somehow we managed, and then today he's a gynecologist, put up in London. He's doing very well. He's doing extremely well there. And how he went there, I don't know. And my friends who were like toppers are now homemakers, or they're not even, meaning, I'm not saying you should work, but they were so good at studies, but they're not putting it to use. Like they're not helping the society in any way. You've gained so much of knowledge, you could do something with that, right? But no, they're just at home taking care of the family. So you don't know, marks are nothing. I'll tell you, just be happy with whatever you get. Take the effort. Take the effort. You should not be guilty of not taking the required efforts. Don't be guilty with your marks. It's okay, just accept it. You study, you take efforts, you will get good marks. If it doesn't happen, just leave it. keep moving. Life is not at all about marks. Some 10 years later, if you think that you got 100 on 100 in your math, in the board exams in mathematics, you think you will be happy that day. You will not care. You will not be able to react to that. On the day you get your results, you will react a week, a month. Then once you enter 11th standard, you will forget it. Then where will you remember some 5-6 years later? You will not remember. So that marks hardly makes any sense to you a few years later in your life. You will forget it. You can't keep celebrating that throughout your life. I got 100 in mathematics or 100 for that matter, 100 in all the subjects in my board exam. Will you celebrate that for the rest of your life? No, you'll forget it at a point. Then after some time, you'll not even think of that. Everybody will settle down well in life, I'll tell you. Today, your efficiency is what matters. Marks are just degree. You just have to study and get a good degree. That's it. And then with your effort, your efficiency, all of us will settle well in life. It really, that's what it is. But I don't know why these exams, competitive exams, push children, targeting marks. You should get this much. Okay. These, whatever we have discussed so far, I'll share the majors on WhatsApp. Now we'll at least take, it's time, but we'll at least take one question as a test. Yes, children, please take down this question. Polynomials. Let's see how much you can recall from polynomials. Yeah. I picked the simplest one because we don't have much time. So this is a very easy one. minus 36 by. Very good. On next students. Very good. Okay, Sashank has already given us the answer. Pratit, what's the first step?
I found
What are the
alpha
values of? Yeah. What's alpha plus beta?
minus 11 by 2,
Yeah, and alpha beta?
5 by 2.
3 by A, 5 by 2. Okay, now 1 by alpha plus 1 by beta minus 2 alpha beta. Let's take up the common denominator. So alpha beta, correct? Or you can
Yes.
take up the common denominator only for these two also. What did you do? What did you do? No. Did you take the LCM for the full thing or only for the first? Yeah, you can do that also. Because minus 2 alpha beta, we already have the value 5 by 2. You can do that also. That's what. See, LCM you can take up only for the first two also. Because minus 2 alpha beta, what is alpha beta? 5 by 2. So why take the LCM for minus 2 alpha beta? You can leave that. You can take the LCM only for these two. So alpha beta. So you'll get beta plus alpha. Minus 2 alpha beta. So that is, what is alpha plus beta? 11 by 2. Minus 11 by 2. Divided by alpha beta. So divided by 5 by 2. Minus 2 into alpha beta. 2 into 5 by 2. Substituting, that's all. After this is only substituting because this is the alpha plus beta, this is the alpha beta, this is the alpha beta. Just substituting the values. After that, it's just substituting the values. Alpha plus beta is minus 7 by 2 divided by. I've used a symbol, division symbol. So that is minus 11 by 2 into 2 by 5. Minus 2 gets cancelled, 5. So here also 2 and 2 gets cancelled. So minus 11 by 5 minus 5. Minus 11 by 5 minus 5. Right? Very good. Done, children? Online students finished?
Yes, ma'am.
If you have not completed, please take a picture. Online students, all of you finished? Okay. Okay, online students use emoji, raise your hand. Very good. Rajat, Florentina, Raghavi, and Rakshita, very good. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Yeah, thank you, children. Good night.
Thank you.
Thank you, children. Good night. Thank you.